So let's talk a little bit about the appearances of Mars and Venus. Venus is an inner planet. That's another name for that is an inferior planet. Those are the names that I think Copernicus came up with to describe Mercury and Venus. Um, so it so it's always within a maximum of 45 degrees from the sun. Remember, we said Mercury is always between 28 degrees of the sun, and that has to do with the fact that we talked about earlier that Mars is that Venus is an inferior planet. It's inside the orbit of the Earth. Venus is the third brightest object in the sky after the sun and the moon. It is brightest seen from Earth because, like Mercury, it's both near the sun and near the Earth. So when we look at it, it's pretty close to us most of the time, and it's pretty close to the sun. Also, it's inside our orbit, and so it gets lit very well, and it's near us. So that's why it's bright to us. Venus has 100% cloud cover all the time, and that makes it bright. Clouds are pretty reflective, so it's impossible to see the surface with a visible light telescope. Venus is way too hot to land probes, and so we don't have nearly as much action going on Venus, even though it gets closer to us than Mars does in terms of landing things on it and exploring it. Mars is much more amenable to that because its temperatures are much more tolerable for electronics. Mars is cold, kind of the way Venus is hot, and so our electronics work better on Mars, so it's easier for us to look there. So let's talk a little bit about Mars. Since its orbit is farther from the sun than Earth, Mars is called a superior planet. This means that Mars is not restricted to being within some fixed angle of the sun. Mars can appear on the opposite side of the Earth from the sun. It's kind of what we drew in the pictures earlier for its orbit. That's called position is called opposition, and that's when it's closest to us. It's about 50 million miles away, and in there is where we make our launches to Mars when it's on the close side of us, not on the far side. This would put Mars overhead at midnight, the opposition position, a place where inner planets can't be. Venus can't be overhead at midnight because that would mean it was on the opposite side of the sun and its orbit isn't there. So and opposition is the best time to look at a planet because that's when it's closest. Mars looks red because, like Oklahoma, it has iron oxide in its surface dirt. Or iron oxide is a fancy name for rust. Mars has a very thin atmosphere, so unlike Venus, which has about 100 times the atmospheric pressure we do, Mars has less than 1% of our atmospheric pressure, and so it's also in many ways easier on electronics. It doesn't have a corrosive atmosphere like Venus has. When you look at Mars through a telescope, just an average telescope, you can actually see surface features on it. You can see polar caps and some of the dark areas that we'll talk about. There's a big to-do about Mars in the late 1800s and early 1900s. An Italian astronomer named Schiaparelli published a paper saying he saw canals on Mars, and canals in Italian translates to channels, but translators use the word canal instead, and those are man-made, and so people thought he was suggesting there were intelligent organisms on Mars, and we went through a long period of time where astronomers, notably an American astronomer named Percival Lowell, were claiming they saw constructed canals on Mars' surface. We have not found any since, but this led to, for example, H.G. Wells' book, The War of the Worlds. Eventually this was all sorted out. So let's start talking about Venus. Venus has a very thick atmosphere, as we said a minute ago, which is fully clouded over all the time, so we can't see its surface with any telescopes, with visible light telescopes, because it's just occluded by cloud cover all the time. So we've sent probes there and mapped out its surface with radar, bouncing radar waves off its surface. Russians landed a probe. It lasted for several minutes, took some pictures, and so we have some surface pictures from Venus. Mars was thought to have life on it based on observation of Percival Lowell in the late 1800s. Okay, comparison of some basic properties of the two planets. Earth and Mars have days that last about 24 hours. Venus rotates about every 243 days. It orbits the sun about once every 220 or so Earth days. So its day is actually longer than its year. It's also rotating backwards. Most planets are orbiting in the same rotating in the same direction they're orbiting. Venus is doing the opposite. So Mars has a day that's about as long as Earth's day, but Venus's day is much, much longer. On Mars, the temperature can get up to 70 degrees Fahrenheit, and the nighttime temperature about minus 100. It depends on the kind of weather Mars is having. Sometimes it has dust storms that affect the surface temperature, but those are rough numbers. The warmest temperatures you'll see are 60 or 70 degrees Fahrenheit. The coldest temperatures are very, very cold. That's much more normal. Venus is an average temperature of about 860 degrees Fahrenheit. This temperature is day and night. Its atmosphere is so thick that it doesn't allow for much cooling overnight. Roughly speaking, the atmosphere on Venus is about 100 times the pressure than on Earth, and on Mars it's about 100 times smaller than on Earth. So Venus has very little atmosphere. Venus is very close in size and composition. Venus has few craters. Indicating an active geology is those volcanoes and earthquakes and those sorts of things. Mars is smaller and less dense, a lot of craters, but not much of an active geology. Mars's geology is pretty much stopped. So let's describe in a little more detail the geology of Venus. Venus is active volcanoes. It has no plate tectonics. Its crust is very hot and wrinkles under convection currents in its mantle. The Earth has continental drift because of the tectonic plates and convection currents in its mantle. Venus's surface just wrinkles, and so it's got a different sort of tectonic geology, I guess you would say. Mars has no plate tectonics. It has a few enormous volcanoes that are long dead. Mars's volcanoes are the result of hotspot volcanism, which is a hot spot in the mantle underneath the crust, except unlike on Earth where you get chains of volcanoes, on Mars the crust isn't moving, and so you just get a giant volcano. So Venus has few craters, but more than Earth, so its surface is somewhat older than Earth's. Again, I said Venus' surface wrinkles rather than having continental plates that move. Venus is just really hot and has an atmosphere that's somewhat acidic, and so we'll just talk a little bit about Venus's atmosphere is carbon dioxide. So I think I have, let me just go back to this sheet again. So if you look at the compositions of the atmosphere, right, the Earth's atmosphere is 0.03% carbon dioxide, 78% nitrogen, 21% oxygen, and a little bit of argon. Venus's atmosphere is 96% carbon dioxide, a little bit of nitrogen, not much else. Mars's atmosphere is 95% carbon dioxide, a little bit of nitrogen, not much else. So they have similar composition for their atmosphere, but Venus is way like 10,000 times thicker, denser than Mars's atmosphere. So Venus has mostly carbon dioxide in its atmosphere, a little nitrogen. So Venus's atmosphere is a victim of the runaway greenhouse effect. Early in the formation of the solar system, the sun was cooler. We'll talk about this later. And Venus had water on its surface as the Earth does. Mars did as well. As the sun aged, it got hotter. This caused Venus to get warmer. This caused water to evaporate into Venus's atmosphere. Water is a greenhouse gas, and so that trapped more heat. This further caused the temperature to rise. And eventually, all of the oceans evaporated into the atmosphere. So it was kind of a vicious cycle. As water started to evaporate, it trapped more heat. The sun was getting hotter. It evaporated more water. It trapped more heat. and so on until eventually the entire Martian atmosphere was in all of Mars's water was in its atmosphere. This doesn't happen to the Earth because the Earth isn't quite that hot, and so when water gets up way high, it cools off, condenses, and rains, and then the rain in the atmosphere on Earth washes carbon dioxide out of the atmosphere, and so that cools things back down again. And so Earth has a little bit of control against that as long as we don't get too much CO2 in the atmosphere. So eventually, all the oceans on Venus evaporated into the atmosphere, and the surface was hot enough that the crust began outgassing CO2, making things even worse. This is a runaway greenhouse effect in which the atmosphere traps heat from the sun to such an extent that the planet's temperature spirals out of control. The greenhouse effect has heated Venus to the point that all its oceans are gone. Venus is so hot that we can't land probes on it. The temperature on Venus is about 860 degrees Fahrenheit. So we're going to talk a little bit about Mars, some of the missions to Mars. I don't really expect you to know the details of these missions. There are a couple I haven't mentioned here. The Pioneers, but the Mariner flybys are good. We had in 1965 and 1971, and then in 76 we had Viking landers. All of the early missions were kind of looking for just exploring the surface and seeing if we could see anything interesting like evidence of life or water or anything like that. It wasn't until, notice there's a long gap here, it wasn't until 1997 and beyond that we started putting effective rovers on Mars and really exploring the surface. The twin rovers Spirit and Opportunity traveled a combined 30 miles. One of them lasted until 2010, so 7 years. The other one lasted until 2018. I think their missions were like 6 months. And so they lasted way beyond expectation and sent back lots of data. They were looking for evidence of water. The reason they're looking for water is water, as far as we know, is required for living organisms to exist. And so we don't find much water on Mars's surface, but there's evidence that there used to be water there. In 2008, the Phoenix lander made a direct measurement of water on Mars near the polar cap. In 2011, a new rover, Curiosity, which is the size of a subcompact car, and it's nuclear powered, so it doesn't need solar panels. All the previous ones used solar panels. Curiosity was sent to study climate and geology and past and present habitability. 10 years later, the Curiosity rover is still operational, still sending back data, still doing experiments. NASA landed the Perseverance rover on Mars in 2021. It's designed to study the rock record and reveal more about the geologic processes that created and modified the Martian crust through time. Each layer of rock on the Martian surface contains a record of the environment in which it was formed. This will be the first time we'll actually send rock samples back to Earth. So in the big picture, we're looking for on Mars is evidence of water and then evidence of past life or organic matter. That's what these missions are about, finding life elsewhere in the solar system. So what did we find? Well, we found dry riverbeds that look like dry riverbeds do on Earth. We found minerals that only form in the presence of water. These are the early missions. We found evidence that water flows on crater walls. So we also found dry riverbeds, I mentioned that, with sort of teardrop-shaped islands. I think I have a picture of those I'll show you in a second. We used spectroscopy to find hydrogen under the ground, which indicates that there's water under there. And the Phoenix lander found water ice in the ground near the polar caps. And so lots of evidence that water was once prevalent on Mars. Like the Moon, Earth, and Venus, Mars has a continental-like highlands and volcanic plains. I spoke about it mostly in the context of the Moon. The Earth has, continental plates and oceanic plains, and the Moon has that also. They have highlands and lowlands, and Mars is the same way. It has highlands and lowlands. The total height range from the lowest point, which is a region called Hellas Basin, where Mars was impacted by a large asteroid. To the top of Olympus Mons, which is the highest volcano, is about 20 miles. The southern half is mostly cratered highlands, so these are older, they're more heavily cratered. The northern part is volcanic plains, similar to the moon, where there are fewer craters on the volcanic plains than there are in the highlands, so the volcanic plains are younger. Um, a region roughly the size of North America is called Tharsis Rise, or just Tharsis. It has 4 volcanoes that are the largest volcanoes in the solar system. The largest one, Olympus Mons, is about 3 times taller than the tallest mountain on Earth. It has very few craters, which means that the volcano is less than 100 million years old, perhaps much younger. It has a rift valley. So a rift valley is what happens when the continent splits. So this bulge in the mantle underneath Tharsis Rise created a split in the crust as it bulged, the way a football will tear or a basketball will tear along a seam when the pressure gets too high on the inside. So I'm just going to walk through some pictures of Mars and Venus fairly quickly. This is taken by the Spirit rover in 2004. It operated from 2004 to 2010. You can see its tracks there. That's a picture of a Martian landscape, which is kind of cool to look at. It looks a little bit like an Oklahoma landscape, maybe, a little more barren. There's a picture of Venus. Venus is completely cloud covered. Here's some pictures of Mars, also taken from Earth. These guys are also, so you can sort of see Mars has a much thinner atmosphere, so you can see right to its surface. You're seeing structural things on Mars's surface as it rotates around. You can also see polar caps on Mars. Even with a modest, sort of family price telescope, you can see some interesting stuff on Mars, at least when it's at opposition. This is a drawing by Percival Lowell, the guy who thought there were canals on Mars, and he was trying to provide evidence that, there were living organisms there, intelligent beings. There's another picture of Percival Lowell. He was very wealthy and built his own observatory and did a lot of cool stuff. Here's a picture of Venus. The blue is low and the brown and white is high elevations, like Earth and Moon and Mars. Venus is high areas and low areas, and so all the terrestrial planets are sort of similar in that regard. These are impact craters on Venus. They're very round. Let's see, is there any? On the right, you can kind of see those ridges. Those are sort of wrinkling in the crust. These are pancake-shaped volcanoes on Mars. These are circular domes. Pancake-shaped volcanoes. So it's evidence that the volcanoes are kind of sludgy, and their distribution is very circular. More wrinkling on Venus. This is how the crust manages stress. Unlike on Earth, where the continents move, they don't move on Venus. The crust just kind of buckles. This is a picture taken by the Russian spacecraft that landed on Venus. There are very few pictures that have been taken on Venus because Venus' surface is so hot. Here's a little description of Venus's atmosphere. It's got a troposphere, a stratosphere, and a mesosphere. It's got some sulfuric acid clouds. There's a lot of crazy stuff happening on Venus. Its atmosphere is very thick. Notice that it's hottest near the ground, just like it is on Earth. Here's a picture of Mars. It's got sort of seasonal caps. It's got permanent caps, polar caps, but it's also, they increase and decrease seasonally the same way they do on Earth. Here's the picture taken by the Viking lander. Again, these Martian surfaces look a lot alike, a lot of rough angular rocks. You can see this sort of the Viking rover over here on the right. Right, it has a little ramp that left the spacecraft on. It goes over and takes a sample and then comes back. And so they nicknamed it Yogi. Here's a crater on Mars. It's 800 meters wide, which is not that big, maybe half a mile. Slightly smaller than meteor crater on Earth, the one in Arizona. There are dunes in the interior. Here's a picture taken of Victoria crater. So here's a teardrop-shaped island in a riverbed. You can sort of imagine that water was flowing. Also, it looks like there's some erosion on this impact crater here, right? So there's all sorts of interesting things going on here. This looks like it was a wet hit. If you compare this to a lunar crater looks much more explosive than these guys do. So here's a fragment of basalt ejected by Mars. We don't have any Mars rocks because we don't have any Mars rocks that we got from Mars because we haven't sent anything back. Our current mission, which is Perseverance, is supposed to send some rocks back. However, we do get Martian rocks from meteorites. Some asteroid makes a big impact on Mars, blows stuff out into space, a few pieces land on Earth, and we can actually figure out which ones are from Mars sometimes. And so this is a Martian meteor, right? Or a Martian rock, if you want to call it that. So here's sort of a picture of the two hemispheres of Mars. There's a lot of information in here, and so I'll just talk about this for a second. So these white spots here are the volcanoes. I can't remember which one is Olympus Mons. Hemisphere left includes stars, rise, Olympus Mons. Highest mountain on Mars. So it's one of those. Here's Valles Marineris, the rift zone on Mars where the crust split. This whole area is raised really by heat from below. But just like on the moon, there are high areas that are heavily cratered and low areas with not many craters. So the low areas are young and the high areas are old. This area is called Hellas Basin, which is actually the lowest level of Mars, but it was hit by some massive asteroid, which blew most of the ejecta out and left a big dip behind. Here's a picture of the Olympus Mons, this gigantic volcano. Just the opening here, just the opening at the top of the volcano is like 40 miles across. So this is roughly, I forget what it is, but it's maybe the size of Oklahoma or something like that. It's quite big. This is the Rift Valley, Valles Marineris on Mars. This is the Viking orbiter showing pictures of one of the valleys in Mars. Let me just work through a few of these pictures today. Yeah, let's keep going. All right, sorry. So these are just, this has frost. So you see the white stuff in this image, that's CO2 that's freezing out of the atmosphere. That happens when it gets cold enough, just like water gets out of our atmosphere at the dew point. These are wind effects. These are dunes created by wind on the right, and on the left is tracks made by dust devils. These are just lines aligned with the wind direction. These are polar caps. So this is when the Phoenix lander found water near the polar caps. Notice it's underground. It had to dig a hole to find water. And when it did, it took a picture of it, and then took a picture of it a day later, and a bunch of it had sublimed. You can see there's a little less ice on the right than on the left after they waited a while and came back. And the evaporation rate, or sublimation, where it goes from solid to gas, is strongly indicates that it's water. So here's more evidence for water. This is, if you look in the middle of the picture on the left, you see channels from ancient rivers. This would look like something on Earth you would see if there was or a river that was forking out in a bunch of directions, just right in the center here. This also looks like a riverbed of some kind on Mars. There's evidence in here of water flow just along these walls. This looks like a dry lake bed here on the left. This looks like sedimentary rock that's been eroded by water on the right. So we have lots of evidence all over the planet of water. So let me go back to talking about a minute ago. Let's just talk about Mars's atmosphere for a minute. Describe the general composition of Mars's atmosphere. Mars's atmosphere is about 95% CO2 and a little nitrogen and a few other things. It's mostly CO2. What we know about the polar caps is there's CO2 and water. The northern cap is mostly water. So there are permanent parts to the cap and then seasonal parts. And during the cold season, since the atmosphere is mostly CO2, when it gets really cold, CO2 condenses down onto the polar caps. And then in the summer, in the northern hemisphere or the southern hemisphere, whichever one you're doing, the CO2 evaporates. So we talked about the runaway greenhouse effect on Venus. Here's the runaway refrigerator effect, or the runaway icehouse effect. So like other terrestrial planets, Mars got its CO2 from its volcanoes, typically. That's what replenishes CO2. And so as on Earth, water from rain washes CO2 out of the atmosphere, and that happened on Mars back when it had water on its surface and a thicker atmosphere. Well, when Mars's core cooled off and the volcanoes died, Mars stopped getting CO2 ejected into its atmosphere, so it stopped trapping heat. As the rain washed the remaining CO2 out of the air, Mars's atmosphere began to cool off. A cooler atmosphere holds less water. This is why you can see your breath in the winter but not in the summer. So now water condenses out of the atmosphere as it gets cooler, and it cools off even more. This spiral effect is kind of like the opposite effect of the greenhouse effect on Venus, is called the runaway refrigerator effect, or the runaway icehouse effect, and that's what's happened on Mars. It drove all the water out of its atmosphere, and there's just a little bit of CO2 left. Describe evidence that Mars once had water. So there's dry lake beds, teardrop-shaped islands and riverbeds, runoff channels, other effects. Water ice found underground near the poles. So there's not much evidence for life on Mars, really. The Viking landers carried out some very sensitive measurements looking for life on Mars back in the 70s and found none. There is water there, and so that's a good indicator. On Earth, everywhere there's water and an energy source, we find life. And so it's possible. What we're really looking for now is fossil evidence of past life. We think it's hard for life to at least exist on the surface because Mars has no ozone layer and a thin atmosphere, and so high energy radiation would be very damaging to organic molecules or organic materials.